Today we'll be talking about dividing polynomials. So we're going to review a little bit before we jump into new stuff. So remember in our first lesson in this unit we divided by monomials, so that's what we're going to review. So when you take this 6x to the fourth and divide it by 3x squared, how many times does 3 go into 6? Well, it goes twice. And then you subtract your exponents, so 4 minus 2 is 2. And then I have 15x cubed minus divided by 3x squared, so it's going to be negative 5. And then x, because you subtract 3 from 2. And then 3x squared by 3x squared just gives me a 1. And if you forget the 1, I'm sorry to say, but it is wrong. And these notes are not as long, so I will do all of the problems. So then number 2, I have 21a to the fifth b cubed minus 14a cubed b squared plus 63a squared b. And I'm dividing that whole thing by 7ab. So I'm just going to take each term, each monomial, and divide it individually. So 21 divided by 7 is 3, and I subtract the exponents of a, and I get 4 left over. And then I have 2 b's left over. And then 14 divided by 7 gives me 2, and then I have 2 a's and 1 b. And then I have 63 divided by 7 gives me 9. And I have 1a, and I don't have any b's this time. Alright, so that is a quick review on how to divide by a monomial. So now we're going to divide by a binomial. So first we're going to factor the top, or factor anything we possibly can, which in this case is the numerator. So what multiplies to 10 and adds to negative 7? Well, negative 5 and negative 2. So I have w minus 5 and w minus 2, all divided by w minus 5. So when you do this, do not cross out just the w's. Don't do it, because you'll be wrong. The entire factor has to be the same. So the w minus 5's here go away, and I am just left with w minus 2 as my final solution. Moving right along to number 4 here. So I have 4h squared minus 7h minus 2 divided by h minus 2. So when I factor this top trinomial, I get negative 8 and negative 7. So what multiplies? Because you have h squared minus 7h minus 8. So what multiplies to negative 8? It adds to negative 7. Well, negative 8 and 1, right? So I get h minus 8 and h plus 1, and then I have to divide by 4. And so this guy doesn't divide evenly, so I have to slide the 4 in front. So I get 4h plus 1. And then 8 minus 4 does divide evenly, and it divides into 2. So then I have h minus 2 on the bottom. Same as number 3, I cannot get rid of it unless it's the exact same binomial on top as it is on the bottom. In this case it is. And the h minus 2's go away, and I'm left with 4h plus 1. Alright, but what if factoring doesn't happen? Like, what if I can't factor? Well, that's where this stuff comes into play. So I'm going to show you 2 different methods. You probably will like the second one better, but you might not. So, bear with me. We're going to do long division first. If you ever remember how to long divide like numbers like you did in 4th grade. So, it is a 4th grade standard, so don't think I'm crazy. Long dividing numbers, not polynomials. So this is your long division thing. This x plus 8 will go on the outside, and the x squared plus 3x minus 43 goes on the inside. So now I want to take the x and figure out x times what will give me x squared. So x times x will give me x squared. So then I take x times x, which gives me x squared, and I always line them up. And then I take x times 8, and that gives me 8x. But I'm subtracting this whole thing from the original trinomial. So the x squareds go away, and I don't have any more. But then I'm given a negative 5x, and you have to bring down the negative 43. So now you are using this binomial to figure out what will go there. So now you have to figure out what times x will give me negative 5x. So negative 5. And then you take negative 5 times x, which gives me negative 5x. Because what you want to do is them to cancel. And then negative 5 times 8 gives me negative 40. And you are subtracting that whole thing, so the 5x's go away. And then I have a negative 43 minus a negative 40, so that gives me a positive 40. So I'm left with a negative 3. And then that is your remainder since we no longer have any x's. So how I would write this is x minus 5, you use the thing on top, this little guy right there, you use him, and you use your remainder. Remainder. So minus 3 over, you're dividing that negative 3 over x plus 8 still. So, or you could write it this way. X minus 5 with a remainder of 3. Either way. I don't care. I'll accept both. However, if you plan to go further in your math career, this is the way they would want it. So, all right. So that's how you do long division. Synthetic division. So, synthetic division is a little different because you have to set x plus 8 equal to 0 and solve. So x equals negative 8. So you use your magic box. And then we're not going to use the x's here. We are just using, go away, we're just using the coefficients. So there's not really a coefficient there, but it's 1. And you got to make sure you have everything. So you have all of the descending ones. So you have to make sure if you start with a squared, you have a squared, you have an x, and you have a constant. If you have a cubed, you have a cubed, a squared, an x, and a constant. In this case, we're good. So 1 is my first coefficient of my x squared. And then I have 3, and then I have negative 43. You want to leave a little bit of space so you can write something in this particular area because we're going to use some numbers. So this is where you bring down, let's use the marker, not the laser pointer. Bring down the 1. So, and then you were going to take and multiply 1 times negative 8, which gives me negative 8. And then you are going to add 3 and negative 8, which gives me negative 5. And then you are going to multiply negative 5 and negative 8 and get positive 40. And then you add and get negative 3. So when you divide using synthetic division, this last number, whatever it happens to be, will always be your remainder as long as you did it correctly. And then you always decrease the exponent or the degree by 1. So we started with a squared, so this would be a linear. And then minus 5 with a remainder of negative 3. Or if you want to write it fancy, either one is your solution. We did the same problem twice, but I wanted you to see how it worked both times. So that is how you do long division and synthetic division. On the next page, you will be able to choose which way you like. I personally like synthetic division better, So I will stick with that method, but if you prefer long division and you would like me to show you long division, just come talk to me and I'll be more than happy to show you the long division way. Alright. So I'm going to stick with synthetic division. So the number that goes in my magic box up here is a 7, because I set this factor equal to 0 and solved. You don't have to write that step out. I hope at this point in your math career you can solve basic equations. And looking at my trinomial, I am not missing any coefficients, so I can go ahead and start. So I have 2, negative 16, and 19. So I'm going to bring down the 2. 2 times 7 gives me 14. Negative 16 plus 14 gives me negative 2. And negative 2 times 7 gives me negative 14. Negative 14 plus 19 gives me positive 5. So that is my remainder. And I started with the squared, so I'm going to end up with a linear term. And I always stick with the way the variable they gave me. If you change it to x's, I won't count it wrong, as long as all the other things you change to x's as well. So that is your solution. And then let's do 8. So 2 is going to go in my magic box. Once again, I'm not missing any coefficients or any terms. So I have 1, 5, negative 7, and 2. So bring down the 1. 1 times 2 is 2. 2 plus 5 is 7. 2 times 7 is 14. Negative 7 plus 14 gives me positive 7. 7 times 2 gives me 14. 2 plus 14 gives me 16. So that is my remainder. And then I started with a cubed, so I'm going to have a squared. And then you just go down from there. So that is my solution. So, missing powers in the dividend. So, that's the thing we've been dividing. So you're going to add in any missing powers with zeros. As placeholders. If you forget to do this, you will get the wrong answer. I can assure you. Every time, you will get the wrong answer. So, what I do when I do this is I write it out. I have k cubed minus 0k squared minus 17k plus 32. It helps me remember when I go to write my coefficients that I know that I'm missing one. So my number that goes in my magic box is negative 5. And then I have 1, 0. And it should be plus 0. 0 can't be negative. Negative 17 and 32. So I'm going to bring down my 1. 1 times negative 5 is negative 5. 0 plus negative 5 is negative 5. Negative 5 times negative 5 is 25. 25 plus negative 17 gives me positive 8. Negative 5 times 8 gives me 40, negative. And then add those two together, I get negative 8. So negative 8 is my remainder. So then I have x squared minus 5x plus 8 minus 8 over k. Well, you could use k's or x's, I don't really care. X plus 5. But don't put a k here if these are x's. That's why I erased it. There you go. That's your solution for that one. last but not least, so I have 4, 3, 1, 0. So I'm missing squared again. So I have 8x to the 4th minus 64x cubed plus 0x squared plus 3x minus 28. And the number that goes in my magic box is 8. Then I have 8, negative 64, 0, 3, and negative 28. So bring down my 8. 8 times 8 is 64. That becomes 0, 0, 0. 0 times 8 is 0. And then I get a 3. And then I get a 24. And that becomes negative 4. With the negative 4 as my remainder. So then I started with a quartic, so I'm going to end up with a cubic. X cubed, and then squared, linear are both 0, plus 3, minus 4 over x minus 8 is my solution. You can write the squared in the linear term if you want, but you do not have to.